Hello, my name is Joseph Abrokwa. In this video, I'll walk you through the design of a simple dual band CP antenna using HFSS. To begin with, I would like to show you the design, a picture of the design. So this is the back view that is viewed from the top. So from the top of the substrate, this is how the bottom of the substrate looks like. And this is the front view. So in this video, I'll design section by section. So I'll start with red, then move to yellow, then the green, purple, and then the brown. So let's begin. First, we'll create a box for the substrate. And we know that a box is three-dimensional. It has length, width, and height. But our design has a square shape. So we'll have two dimensions. We'll have the length and then the height. So let's double click this, change the name to sub for substrate, then the material is FR4. So select this, let's make it a bit transparent. Okay. Let me turn off this ruler and change the orientation. Okay, now we have to give the dimension. So we have position and coordinate system, and the value for the coordinate system is the global coordinate system. That's the axis here, the coordinate system at the center of the substrate. And we want to have the coordinate system at the center of the substrate. Right now, it's not at the center. You see, it's at the bottom of the substrate. So we want to make it be at the center. Before that, let me enlarge the coordinate system. Okay, let me go back to top, or then back to the position. So now the position it has three columns. The first one is X position, the second is the Y position, and the last is the Z position. And it's the starting point. So the substrate, as I said earlier, has two dimensions. So use variables to represent the dimensions. So for X size, which is the red line here, so the total X size, let's use variable XL, which is 20 millimeters. And then the Y is the same as the X size. So we have XL2 here. And the Z size, let's use H for the height. So we have 0.8 millimeters. Now, the starting point. For the x-axis, we will start from negative half of the total x length. So we'll start from negative XL on 2. Then we'll move, we'll move a distance of x size. So we'll move a distance of 20 millimeters. So we'll get to positive 10 millimeters on the x-axis. So the same is for the y. So negative XL on 2. And the H2 is negative H on 2. Then we go to Victor. Now, as we can see, the coordinate system is at the center of the substrate. Let's go back to top and Victor. Now, we'll start with the red section. We can see that it's at the edge of the substrate. So we'll start from positive half of the x size length. So let's create a rectangle, and let's change the color to red. Let me make the substrate transparent, fully transparent. Okay. Now, so the I'll use variables in this way for the subsections. So for the red, the x size will be rx, and for the y will be ry. So when we get to the purple, it will be px and py. So px for the x length for the purple section, and the py for the length of the purple section in the y-axis or y direction. So start from positive xl on 2. Then the y is we start from negative xl on 2, but we'll add a distance to it. So let's say space. Then since we are on top of the substrate, it's positive h on 2, so the top half. Then space is 4.8. Then the x-axis, as I said earlier, so this will be rx, which is 2. Then this is ry, which is 2.5. So this is minus. So yeah, this is okay. We draw another rectangle for the yellow section. So this is the next section, and it starts at where the red section ends. So we have xl on 2 minus rx. Then the y is negative xl on 2 plus space plus, let me put into brackets, rx on 2 minus, this will be yellow, so it's yy. So y on 2. Then you have h on 2. Then the y is 0.5 millimeters. So the x is yx, negative yx, we are moving in the negative direction, and that is 1.5. So I think we have to correct something here. So this is ry, sorry, this is supposed to be ry. Okay, draw the next section, the green section. So if you want to act lazy, let's copy this. Let me copy this and edit this. so that will not waste much time. So this is, and this is green exo minus GX, and that one is 0.5 millimeters, and this is GY 4 millimeters. So the X is go minus YX, then we'll change this to GY. Yes, we'll go to the purple. Let's change the color to purple. The dimensions, so we can copy these two and edit. So the X is negative px, and the Y is py. Negative px is 10.7 millimeters, and this is py is 2. Let me edit this. So XL on 2 minus RX minus YX minus GX, and the Y is this minus GY. Yes, I think correct. Then we do the last one, which is the brown section. Let me copy these ones again. Then this is brown X. This is coming 1.5, and BY. This is 5. Let me change this. Minus YX minus GX minus PX plus, we have another space here, so let me make this space 1. So this is plus, so it will start at the positive edge, will go in the negative direction RX, a distance of RX, move another distance of YX, another GX, PX, then it will move in the opposite direction at a distance of space 1. Then there for the Y we have negative XL on 2 plus space. We can just add this, can change this, plus PY. Then the space X is 6.7 millimeters. Let me apply this. Okay, so let's correct this. So minus, no, plus R Y on 2 minus GY on 2. So this is it. Now we are done with the top of the substrate. So let's unite these sections. So we click and hold the control, then we select. Then we click on unite. Let's change the color. Let's okay, let's hide this. We'll hide this and then work on the ground plane. So now we are moving to the bottom of the substrate, which is negative h on 2. So let's start this ground plane. Let me change the color to red. Then we add a dimension. So this is, we are starting at xl on 2, the y negative xl on 2, and now we are at the bottom, so negative h on 2, and the x size is now I'll use the direct values. I'll use the direct value. So we'll move negative 5 millimeters, and the y is xl. Go to the yellow section. So this one is xl on 2 minus 5 millimeters minus 1.1 millimeters. Then the y will be negative xl on 2 plus space. No, this another space. Sorry. So let's name this space 2 plus space 2 negative h on 2, and space 2 is 5.2 millimeters. Then the x size for the yellow is 2. So let's make minus 2. Then the y is 5.1 millimeters. Okay. So let me change the color to yellow. Now go to the green and change the color to green. So we have xl on 2 minus 5 millimeters minus 1.1 minus, okay, it's okay. Then we have negative xl on 2 plus space 2 plus 5.1. Then we have negative h on 2. Then we move a distance of 7 millimeters. Then the y is 1.2 millimeters. No, this should be minus in the opposite direction. Then we add the last section on the ground. So xl on 2 minus 5 minus 1.1 millimeters minus 7 millimeters. Then we have negative xl on 2 plus space 2 plus 5.1 millimeters. Then negative h on 2. Then the x size is negative 1 millimeter. Then the y is 2.4. So this 2 is negative. Okay, then the x is positive. Okay, so we unite these two as well. Then we will assign boundary. We'll assign a boundary to these 3: rectangle 1, rectangle 6, and rectangle 9. So let's select them. Then right click, assign boundary, perfect E. So let's show all objects. So now we have everything. So now we will design the excitation port. So let's change the plane to YZ. It's at the side. So this is the feed line. So that's where we design the ports. So let's change the orientation to front and draw another rectangle. And this is XL on 2 minus XL on 2 plus space 2. And this is minus H on 2. So the Y is RX, no, RY. Sorry. And this is H. Yes. So you can rotate and see. You can click on Alt and then use the left button to rotate. So it's not, I made a mistake here, let me correct. So XL plus, no, this is space 1, sorry. Just space. Okay. Now we assign a citation. First, let me front Victor assign citation lamp port. Click on next. None. New line. Next. Finish. So now let's go back to our old plane, the XY, and move to the top. Fit all. Now we right click the workspace and then move to create open region. Now our operating frequency is 5 gigahertz. So click on OK. Now we need to do the simulation setup. So we go to simulation, click on simulation, setup, advanced, 5 gig. Let's make this 10. Then click on OK. Then we should start from 1 to 10. Then let's select discrete for now. And then we'll click on OK. Let's save this at desktop. HFSS. So projects. So this is CP. You can say CP dual band. Let me close this. Now let's do the simulate results. Let's create the reports for the results and then we'll simulate. So we will need X11. Sorry. Let me go to, so this is discrete. Okay. Then single. So I think create model. Let's create field reportings. No, let's go back. So yes, we need S11 new reports. Okay. We need axial ratio plot. So axial ratio. So let's sweep primary sweep frequency. Make this 0. Make this 19. New report. I'll create another report, that's the radiation pattern. So for the radiation pattern, we would first let's insert far field setup infinite sphere. Then let's change this to 360. I think this is okay. Then we'll go back to create far fields reports radiation pattern. We'll select sweep and then select infinite sphere. Select gain. Let's select gain phi and then dp. Then the phi is 0. Let's select this around 5, 5, 5. This is okay. Let's select 5. So 5 is okay. Then new report. So start the simulation. It will take time. I'll end the video here. Then I'll make another video on plotting these results in Origin Lab. So see you. Bye.